Okay, as we mentioned in the first video, we have to create those resources in this solution to make it a secured DMZ. So let's go to the deployment guide and the demo. So here is the Transit VPC with FTD virtual deployment guide, F right. So if you go here and you will see all the solution descriptions here, and the resource should be created by the Transit VPC first. Let's take a look. So I have created the Transit VPC before this demo, and it is the Transit VPC launched from the Amazon Marketplace. If you have not done that, I suggest you do that before you watch this video, and you should find those information on the Amazon Marketplace if you search Transit VPC. And if you take a look at the output the Transit VPC solution has built, you will see there are two CSR created, and these are the IP. Those are the spoke tag you gave it, and it will automatically build the IPsec VPN with the Lambda function. And if we go to the VPC, you will see the Transit VPC. If we go to the EC2 instance, you will see those two virtual machine CSR is already created. So that's the resource should be created first, and those are the resources need to be created in this demo. The section 2 is how to create the Spoke VPC. This is not the focus of this deployment guide, so I have already created the Spoke as well. So you can see the Spoke here, and if you click the virtual private gateway, there's a Spoke already attached to the Spoke VPC, and you can see I gave it the tag as true, and the VPN connection, they are up, and you can see there are routes learned. Okay, and I also create another virtual machine in that Spoke as a Linux virtual machine. The private IP is 20.0.1.4, so it's the 1.4 IP I have already created. Okay, so let's go straight into the section of how do you create FTDv, how do you create FMC virtual. So let's click the launch instance. Select the Amazon Marketplace, and let's search for firepower. Now you should be able to see two firepower appliances. One is FMC virtual, the other one is FTDv virtual. So let's choose FTDv virtual first. It will only allow you to choose the C4 X large, so let's click next. And now let's choose the Transit VPC, and we choose the subnet 1. As I've told you, we will put the FTD virtual in the same subnet as the CSR1. We have to add two interfaces in order to make the FTD virtual to boot up correctly. So let's click next. Skip the storage, skip the tag, and come here. And we'll just create a new secure group. Review it, and launch. And with the key I already download. Okay, so the FTD virtual is created. So let's give it a name called FTDv. The boot up or the creation normally will take 10 minutes. So in the meanwhile, let's create the other resource at the same time. So let's go to the Elastic Network Interfaces. Network Interfaces, and we create an interface called FTDv inside. And for the subnet, we have to choose the subnet that will fit for the FTDv. So I didn't create it in the before the demo, so let's create it in this demo. Let's go to the VPC and go to the subnet. Create a subnet named FTDv in subnet. It's in the Transit VPC. As we have already mentioned, let's take a look at this slide here. So it's gonna be 4.0, 10.0.0.4.0/24. Before we create the subnet, we want to make sure this subnet is in the same AZ as the CSR1. So let's go to the EC2 instance here, and let's select the CSR1. You can see this is in US West 1A, so we have to choose the availability zone as 1A and create it. Okay, and now let's create the FTDv out subnet that will sit in the same sub availability zone. So it's 10.0.7.0/24. As you can see here, it's 7.0. We have to choose the Transit VPC as the VPC. Okay, we continue to create the subnet CSR1 FTDv. Still in the Transit VPC 1A 10.0.5.0/24. That's in the same AZ1. And let's create the CSR2 FTDv subnet. Well, in the Transit VPC, so this one is gonna be in the AZ, the same AZ as CSR2, so it's US West 1B. This is gonna be 10.0.6.0/24. If you take a look here, that's 6.0. Okay, those subnet has been created. So let's continue to create the route table as well. So the route table is here. And we have to find out which one is the management route table. So that route table is created by the Transit VPC itself. So this one is the management route table. As you can see, the default route is pointing to the HW. So let's associate the FTDv out with that route table. Let's choose the FTDv out. And as you can see, the subnet 1 and subnet 2 is already associated with that route table as well already. Okay, now let's create the FTDv route table. FTDv route table in the Transit VPC. Let's associate with the FTDv in CSR1 FTDv, CSR2 FTDv. Let's see, as it's already listed here, so we just follow the slide. Okay, after the FTDv route table has been associated with the correct subnet, let's go back to the instance. So as you already noticed that when we create the FTDv, we create a security group to allow type of the SSH ICMP packet. So we will create the inside interface in order to bind it to another security group. Let's create another security group here. So we just name like allow all traffic. And we put in the Transit VPC and add rules, so just allow all the traffic because this is on the inside. We don't want to bind anything on the security group side. So let's put anywhere and create. Okay, so now let's go to the network interfaces tab and create the instance called interface called FTDv in and choose the subnet FTDv subnet. Choose the security group we just created, and for the IP address, let's just use the 4.4 I created on the slide. Okay, so this one has been created. Let's find the FTDv description and let's give it a name so for better understanding. So that's the second one. Okay, and now let's continue to repeat the step to code FTDv out. This is in a different subnet, but using the same security group, and we put the 7.224 that will follow the same IP address on the slides as well. So let's find this one. So it's the first one, FTDv out. Give it a name for better understanding. Okay, so this two has been created successfully. Because these two interfaces will be used to forward the traffic, so let's disable the source and the destination check. Okay, so now the source and destination check has been disabled. Let's go to the step 5. And under step 5, we will see the FTDv interfaces. Let's go to the instance here. And we can see the FTDv, it's running, but it's not fully up. So when it's fully up, it will be 2/2 check. And that's attached the interfaces we just created to the FTDv instance. Let's attach the inside first. Select instance FTDv and attach this interface as well. FTDv. Okay, now when we go here, okay, so it's fully boot up. It's 2/2 checks. And if we click here, we'll see it got 4 interfaces. Now let's create the FMC virtual. Launch the instance, select the Amazon Marketplace, and search firepower. And now let's choose FMCV virtual. It will also give you only one option. Oh, 2 options. Let's choose the smaller instance type. And here we will put in a different subnet, as you have mentioned. Noticed it will be put in the subnet 1 in the Transit VPC. So subnet 1. Okay, and now let's click next. Just use the default and just create the same, follow the default configuration. Choose the key I already have and launch instance. And normally the FMC virtual will take more time because it will spin up a lot of function inside of the virtual machine, so it will take probably 20 or to 30 minutes. So let's give it a name called FMC virtual. Okay, so I will pause the video for a short while and we'll come back. Okay, after a couple minutes, the FMCV has been successfully boot up. As you can see, it's 2/2 checks. So before we log into those 2 FTD virtual and FMC virtual, let's create the elastic IP for them. So let's create 2 elastic IP and create another one. Okay. Let's associate the first one to the FMC. So it's FMCV. This is the private IP. Associate. Okay. And now, since the FTD virtual has 4 interfaces, we will specify which interface to attach the elastic IP. So let's attach it to the first interface. So the elastic IP, the interface ID, I just copy it and go to the elastic IP. I will associate the IP address, select the network interfaces, put the interface here. Okay. Now it will use this interface to associate. Okay. So now we have the FMC and FTD virtual. So let's go to the FTD virtual first. So this is the public IP. Let's open the terminal. So, okay, let's do SSH. Let's make it bigger. Okay, sh-i transit admin. Okay. So when the first time you log in, it will ask you to change the password. So let's change to the Cisco 123, Cisco 123 with capital C. So this is the password I have put. Okay. Now, yes, yeah, no, just configure as default. So just go. Let's go. Okay, it will take some time for it to change those configurations. Okay, so in the meanwhile, let's go to the FTD FMC virtual. And let's choose the FMC virtual IP address. Okay, now we are inside of the FMC virtual. It will ask you to enter a new password. So let me use the other one as admin123 for this password, because we'll change it again when we log in from the GUI. So admin123. Okay, so it asked me to access from the HTTPS link. So let's go to the GUI and come here. And we just put the IP and put HTTPS. Let's do a refresh. Continue. Okay, so it asked me to log in. So I'll put my username as admin. The password I just put admin123, capital A. I don't have to save the password because I will be redirected into FMC virtual GUI. So it will ask me to change password again. So that's why I put admin123 as the first change, and the second change I will use the Cisco 123, capital C. Cisco 123. Cisco 123. For the other part, I just leave it as default because you can see it can read the IP address 203, and it will read the DNS automatically, so I don't have to change anything here. And the DNS, you can see it can be also read as well. So the license, I will just use evaluate license. I don't have to put license here. So let's put apply. This time I can save the password because this is time the password will be the 6123. So as you can see, this is in the first time, and then we can use 6123 as a second change. And this will take another 10 minutes. So I will pause and come back later. Now you can see the page is redirecting me to a private IP because the private IP is the private IP the FMC virtual machine has in the Amazon cloud, but I cannot access the private IP, so I have to change to the public IP. So let's get the FMC virtual public IP again, and let's come to the page here, put IP here, and use HTTPS. Okay, now I'm just log into the FMC virtual machine. If we click device, this is FMC console or portal. If I click device, I think there's no device here. Let's configure the FTDv to register to this FMC virtual. So let's go to the FTDv console again. Let's configure manager add 10.0.1. So let's take a look at the IP address we have for the FMC virtual. It's 0.205. IP here. Okay, and we need to put the key. So I just put Cisco as the key. It will take several seconds to digest the configuration. So in the meanwhile, let's go to the GUI, and then we go to the FMC virtual. Okay, so let's add the FTDv device on the FMC virtual. So let's click add device, and we have to find out the IP address. So if we click instance, so this is FTD, and then this is the, so we have to use the first interface IP. So it's 10.0.0.241, and we host name, we name it FTD virtual, and the key is the key we have used, so that's Cisco, and we have already created the FTDv policy. So let's just enable all the features and click register. And now, normally it will take around 10 minutes for you to register all the functions and downloading all the signatures to the FTD. And let's resume after it has been registered. Okay, now after 5 minutes, the FTDv has been successfully registered on the FMC virtual. So you can see this FTD is listed here, and if we go to the console of the FTD, if we do show managers, so we should be able to see the registration is completed. Okay, so let's move on to the next step. Let's enable the interface of the inside and outside on FTDv virtual. So since the FTDv has been registered on the FMC virtual, so all the configurations will be done on the GUI or on the portal. So all the subscript configuration will be done on this portal. Okay, so let's go to the device management and click this FTD virtual. Let's click on interface, and now as you can see there are two interfaces, a gigabit 0/0 and 0/1. That's our inside and outside. So let's click this one, and let's give it a name. The first one is gonna be the inside interface, and we click enable, and security zone, we create a new one, let's call it inside. Then we click the IPv4 and use static IP, and we will choose the IP that's configured on the third interface of the FTD virtual EC2 instance. So if we click the FTDv virtual, and we will see there are 4 interfaces. So the third one will be used for the inside. So it's 4.4, that's the IP address. And here we click OK. And also let's configure the outside at the same time. So we'll put outside, create a new zone called outside, and we click IPv4, we'll grab the fourth interface's IP. So it's 7.224. We go here, put here, and /24. Now we click OK. So the configuration will not be pushed even you finish this type of this step. So you have to click save, because it's telling you have unsaved configuration. And until now, the configuration is still not pushed. You have to click deploy, and you select this device and you click deploy. And now the configuration is deploying to the FTD virtual. And if you click this icon, you will see the status of the deployment. And it will take some time. It's still in progress, and I think it will be successfully pushed to the FTD in a couple of seconds. Okay, so let's just continue. As we have already mentioned about in the beginning, that the Transit VPC will use different VRF for different spoke. So in this case, I have already created spoke A. So if you go to the CSR, you will see the spoke A's configuration on the CSR. So there's a VPN configuration, and this number will change because every time it will just create a VPN based on a different name. Okay, so let's take a look at see if the configure has been pushed. So let's click this one. Okay, so the deployment to device successful, and it used 37 seconds. Okay, so let's get back to the deploying steps. So this is the spoke A's configuration on the CSR. So let's try to verify it. If we go to the EC2 page and we choose the CSR1, for example, and let's select the public IP, and let's open 2 new terminal so we can see. So actually I can close the FTDv because all the configuration will be done on the bottom. I can close this one as well. So let me close those one. Make it bigger. Okay, so this is the CSR1. Okay, and let's select CSR2. I think this is CSR2. Okay. Okay. So we can see the tunnel up. Okay, let's do a show run. Show IP VRF. Show VRF. Okay, so this is the VRF that's created for the spoke A. And now let's add another VRF for the FTD. So let's copy this configuration. The formatting probably will change, so let's see. Okay, let's put here and add this to the console. Both of the CSR. And we need to create an interface for the CSR1 to connect to the FTD virtual, and also the CSR2 interface to connect to the FTD virtual. And we will also specify the IP address, and please remember that the availability zone should be the same. So let's see the CSR1 is in the 1A availability zone, and CSR2 is in the 1B. So let's go to the network interfaces, and we create a CSR1 FTDv, and the subnet will be the CSR1 FTDv, and we assign the IP 5.5 and just use this security group. And now we'll see this one is created, and we give it a name, and we create another one called CSR2 FTDv. We choose the CSR2 FTDv subnet, and we create the IP allow. Okay, and this is CSR2 FTD interface we just created. Give it a name. Oops. Okay, so we have created an interface, and now we attach the interface to those two. And before we attach it, let's disable the source and destination check. Disable. disable. Okay, let's attach this interface to CSR1. And also let's attach this interface to CSR2. Okay, now if you go to the CSR, you should show IP interface brief. You can see the gigabit 2 and the other CSR gigabit 2. So let's give the CSR name so better recognize it. So the CSR1 will be transit CSR1. The CSR2 will be transit CSR2. Okay. So as I've mentioned before, the gigabit 2 should be sit in the FTDv verb in the CSR1 and CSR2, and also some static routes has to be created so they can talk to the FTDv through that interface. So let's continue on the guide. So make sure the gigabit 2 are under the VRF we just created. So let's go to the gigabit 2 IP VRF forwarding FTDv IP address 5.5 for the CSR1. Okay, now the CSR gigabit 2 interface has been up, and let's do the same on the CSR2. Gigabit 2 IP VRF FTDv forwarding FTDv 0.6. Okay, so now it's up, and let's add the static route. So the goal or the purpose of to add this static route is, if you remember the 4.0, that's the FTDv inside subnet, and we will tell the CSR to reach to the 4.0 through the 5.5 interface for the CSR1 and through the 6.6 interface for the CSR2. Let's add the static route. IP route VRF, because this route is in the VRF, so 10.04.4. So we should use the Amazon gateway. So if you look at the gigabit 2, it's in the 5.0 subnet, and the Amazon gateway is always the first IP address. So we will use the 5.1. Oops. Okay, and we'll add the same on the CSR2 as well. So go to the CSR2, config IP route VRF FTDv 0. On the CSR2, it's using a different subnet for the gigabit 2, so it's 6.1 for the internal gateway, Amazon gateway. Okay. So now that's one static route add on the one side on the CSR side. So we have to add the static route on the FTDv side as well. So let's save the config first, and then we should go to the FMC virtual to add the static route on the FTD. So let's go to the firepower management, and we will click the device. It has a routing tab. It's loading, and now we click the selected static route and add a static route. Let's add a network first. Okay, to CSR1 5.0.24. Say, and we'll add another one, 10 to CSR2 10.0.6.0.24. Okay, and we will choose the two sub we just created, the two network objects we just created, and we'll put the Amazon internal gateway. So remember, the 4.0 is the FTDv subnet, inside subnet, so we'll use the first IP 4.1 as the static route, and we click OK. Oops. And we should use the inside interface, sorry. Now we click OK. So let us add another subnet. So this is will be another static route to reach out to the internet through the outside interface. So let's choose outside, and we create a default like routes outside default routes, and we put 0.0.0/0. Select this one, and the gateway will use the outside subnet internal gateway, so it's 7.1. Okay, so as we have done this before, we have to save the configuration first, and then we have to deploy. Let's click deploy. It will also take a couple seconds. After the FTDv configuration has been pushed, we should be able to pin those FTDv inside interface from CSR's second interface in the FTDv wharf. And then the BGP control plan has been built up, and we can continue to configure BGP, and we can fix the data plan as well. Okay, so you can see the deployment to device has been successfully done. So now if we go to the CSR1 or CSR2, it doesn't matter, we pin VRF FTDv. So if you still remember the IP 4.4 source gigabit 2. Okay, now you can see it can reach out to the FTDv inside interface through the CSR second interface. Okay, cool. So let's continue. So we have done the control plan IP connectivity has been built up. Let's enable the BGP. Since this is gonna be a multi-hop eBGP, why it is multi-hop? Because as you can see from the topology that we have shown here before, the FTDv, the CSR1 FTDv is in a 5.0 subnet, and the CSR2 is in a 6.0 subnet, and this FTDv inside is a 4.0 subnet. So those are three different subnets, and the IP connectivity has been built, and the BGP will be an IP multi-hop because they are not in the same subnet, and they will be connected by the FTDv route table or Amazon internal gateway. So we will go to the FTD to configure all the BGP part, and then we'll go to the CSR. Okay, so let's go to the FNC virtual, and we click the BGP IPv4. Now let's select let's enable BGP and add a number 65002 as AS number. Okay, and now we will save. And now we'll continue to configure BGP, configure IPv4, enable IPv4 address family, and we will add neighbors. Okay, let's click add. Now this is the IP address, the neighbor IP address. So it will be 10.0.5.5 for the CSR1. Remote AS, so let's check the AS number. Show run BGP. Show run BGP. Okay, so it's 64512. Let's put here. And enable addresses. And go to the routes because we want the FTD virtual to send the default route to the CSR. So the CSR will redirect all the traffic to the FTD. So let's enable the generate the default routes. And we'll also configure this multi-hop eBGP to use 255 as the TTL as the maximum hop. So we click advanced, and we click allows connection. That's not direct connected. a limit. Let's put 255. Okay. Now let's do the same for the CSR2. 10.0.0.664. CSR2 is also using the same AS number, so let's make sure. So 64512, enable IP address, and we will generate the default route as well. And 255. Okay. Now everything is done on the FTD. Let's save it and deploy it. So never forget to deploy it, because sometimes you don't deploy, you think the configuration is pushed, but not. So it's very hard for you to troubleshoot it. So every time just deploy it. So it will take some time. In the meanwhile, let's go to the CSR to configure it. So those are the configuration we are to add to the CSR. So let's copy those to the edit here. So neighbor, because of the formatting will change a little bit. So let's adjust it first. Okay, we don't have to create those two because I use a two FTD in my previous lab. So let's remove one. Okay, because if you remember, we create the 65002 as an AS number, so let's use this one. And we will change the IP address. This IP address will be 4.4 because this is inside IP. Okay, and now we can copy this configuration to the CSR1. So before that, let's see if the configuration has been pushed. Okay, so it has been done. Let's go to the CSR1. If now you do a show BGP OR. For the FTDv VRF, you only learn the routes from the spoke, right? You don't see the default route. So let's enable the BGP first. Configuration, just copy that. And save the configuration. We'll do the same on the CSR2. Save that. Now if we do a show BGP OR, okay, you see the default route that's coming in FTDv VRF, and the next hop is 4.4. That's the FTDv inside interface. And let's check on the other CSR. Okay, it's also here. It's also here. Okay, so this is the default route at FTD virtual sent to the CSR to redirect the traffic. And if you on the CSR1 you do a show IP route via FTD, you will see the default route. It learns from BGP and it will redirect to the 4.4. And also, if you do show IP VRF, this is the VPN VRF, the Spoke A VRF. So if you do show IP route VRF, this VRF, you will see the default route is also learned from BGP, and next hop is 4.4, but it's in another VRF. So every traffic that hit the VHW go to the VPN VRF in the CSR, and it will be matched on this default route, sent to the FTDv VRF and sent to the FTDv 4.4 interface. So that's how the traffic got redirected. And now if you go to the Spoke route table, so let's go to the VPC and let's click the route table, and we'll see the Spoke A's route table, routes. Let's do a refresh. So the route propagation is not enabled. Let's enable route propagation. Okay, so now you can see the routes. So the 5.0 and 6.0, that's the the CSR1 and CSR2 second interface IP. Why it's listed here? Because if you remember, the configuration we put down has the redistributed connected. So that's why it's here. If you don't want to see that route, you can just remove the configuration. And now also you can see the default routes. The default route is learned from the VHW because the VHW is learned from CSR, and CSR is learned from the FTDv virtual. So that's how the default route got to be propagated from the, if you go up here, propagated from the FTD to the CSR, CSR to the VHW. That's how it works. So the BGP control plan configuration has been done. So let's go to make sure the data plan works. As I mentioned, this is a multi-hop eBGP, so the traffic will hit the internal gateway, and the internal gateway will have to know how to forward the traffic, or otherwise the data plan will not work. So let's go to the Amazon internal gateway to make sure it works, and we go to the FTDv interface. Let's click the instance. This is FTDv, and we will use the inside interface. So that's going to be the third interface as the next hop for the internet traffic. And then we go to route table FTDv first. For this step, let's just leave it as now, and we will revisit it later. So we go to the FTDv route table, and here we'll add another route. Sorry, that's the internet route. So every internet default route will go to the CSR. CSR will forward to the FTD, but before the traffic go to the FTD, it will hit the internal gateway. So that's why we will use FTDv inside interface as the next hop. So save it. And for the return traffic as well, for the Spoke traffic, we have to let the internal gateway knows how to forward it. And actually, for this type of solution, the Amazon route table doesn't support the equal cost multiple paths, the ECMP. So we'll use CSR1 as active, and you can always configure the CSR2 as a standby because we support the general HA on the Amazon, and you can see the configuration guide here. So let's use the CSR1's interface as the active. If we go to the CSR1 and we choose a second interface, because that interface will be used for the return traffic. Click, copy the ENI number, and we will add to the Spoke. If you remember, the Spoke subnet is 20.0.0/16, and we add this IP. Now we save it. Okay, so all this part has been done. The data plan has been fixed. How do you verify the connection? So let's go to the enable NAT, and we can enable all the connections. So let's assign an elastic IP here. Let's assign to the, okay, so before we assign the IP, let's check the FTDv outside interface, ENI. So it's this. So the force interface will be used for the outside, and the NAT will be happening here. So let's select network interface. Okay. Select IP and associate. Okay, it has been associated, and we go to the FMC GUI and configure all the NAT. Click the NAT. We'll add a NAT rule. Let's add an auto NAT rule. So we create an object as well. So Spoke 120/16 and allow override. And we'll choose dynamic inside interface, destination outside interface, original source, Spoke 1 we just created, translated interface. Okay, that's it. So this is for the inside to outside, and we also want to add outside to inside net. So we can SSH to the virtual machine from the internet. So let's save the configuration first, and let's click object and object management. Add an object. Let's give it a name, VM host. And the IP will be the IP for the virtual machine, and we have to select override, save. Okay, now let's go back to the net again, device management. Click the FTDv virtual and click net, and we create another net room. So we choose AutoNet as well, and this is the static. So this is from inside to outside, and we select the VM host. So SSH use TCP/22 port, and we'll use interface, and we'll use the 5001 as the PAT number, the port net number, or the port address translation number. So let's save it. Let's deploy it. It will also take some time. So in the meanwhile, let me take a look at the IP. So this FTDv virtual will have a this interface that has a public IP. So let's refresh it real quick. Okay, so this is the elastic IP. So I think you probably already noticed that it has another public IP. So this first EIP is the IP we try to manage it, but you can just remove it because we don't need it anymore, because the FTDv virtual is managed through the FMC virtual. And the second EIP is the one that's titled or bundled with the last interface, Ethernet 3. So I already copied this IP, and now let's go to here to see. Okay, so the deployment is has been successfully done. And before we SSH to it, we have to enable the policy to make sure the FTDv has the right policy. So let's go to the FMC virtual and click policy. This is policy we just created. Let's double click it, and then we need to add some rules. Okay, so we click allow traffic. So we have to select ports. Let's select. Okay, so let's make it a little bigger. Okay, so let's select Smp. Let's select HTTP first. Source, destination. Let's add them both, and also the SSH telnet. Telnet. Okay, so Smp is not here. Let me see. Let's just add those first. Okay. Okay, so let's add the Smp manually. Let's click the edit, and let's find the port, and we add the Smp port. Smp-transit choose SMP, and we will choose any, and we can create this one. Okay, so now you can see this one, and we can okay, so let's click policy, FTDv virtual, and we create another rule. So let me make this bigger. Rule 1. Let's click the ports, select the ICMP, add, and let's add the HTTP, HTTPS, and also the SSH and telnet. So SSH telnet. Let's click OK, and then add another rule, a specific rule to deny it. So rule 2, deny block. Okay. So save it and never forget to deploy it. Okay, while it is deploying, let's try to get the IP again. So the second IP, right? So if you remember what I have just mentioned, second IP. And if you remember, we enabled a 5001 as the port net. So let's see if this has been deployed. It will take a couple minutes or a couple seconds. Just wait. Still deploying. Let's go to the right folder. Okay. And sh-i transit. So the IP will be a little different. So it's gonna be EC2 user at this IP with a port 501. Okay. So 501. Okay. Now deployment has been successfully done, so that's SSH. Okay, so now try it again. Okay, it asks me to input the. Yes, okay, so we are in the virtual machine through the NAT configuration. So if config, this is the Amazon AMI. If we try to ping Google, okay, you can see the ping is go through. And if we want to try HTTP, let's do a wget, www.google.com. Okay, you can see the download is happening, and there's an index HTML. Okay, so you can see this is all Google stuff, right? So the HTTP works, and let's try the HTTPS. Okay, so you can see the HTTPS is still works as well. And those are the configurations, other web pages. Okay, so let's go to the FMC to see those traffic. If you go to the FMC, let's go to the dashboard. So dashboard. It will take some time, so let me see. Let me refresh. As you can see, that's updated 4 minutes ago, so we just did the ping and the wget. So let's wait for another refresh cycle. Okay, so now if we do a refresh again, you can see you should the Google, the SSH, or the configuration you can, the event you can see. If you click any one of them, you'll see the detailed information here. Okay, so let's go back. Let's try another thing. Let's remove the HTTPS from the policy. So if you go to the policy, then select this one, and let's remove the SSH. Sorry, the HTTP port. Remove it. Let's save it, and let's deploy it. And now you should not be able to do a wget to the HTTP URL, but you should be able to do the HTTPS because HTTPS is still here. So let's see how it works after the configuration has been deployed. Let's do a refresh. Just still deploying. Okay, so now we can still SSH because the SSH is not blocked. Okay, so so it's deployed. Let's see the HTTP. Wget HTTP. Okay, you can see the connection has been blocked. You cannot do HTTP wget, so the port 80 has been blocked. But we should be able to do the HTTPS, which is port 443. Okay, you can see the 443, the HTTPS is still working. Yeah, that's pretty much of the demo. So in this demo, I have showed how you can turn on the FTD, and then, so let's go back, do a small recap. So in this demo, I have given you the idea how you can extend your existing Transit VPC into a secure DMZ by creating two FTDv and FMC virtual and connect them together using the subnet route table and then configure the FTD FMC to enable the IPS, to enable the NAT, so you can SSH into the virtual machine and do ping to reach out to the outside from the virtual machine by using the elastic IP on the FTD. So that's pretty much of the demo. And in the next video, I will show you how you can automate this part with the CloudFormation template and the Lambda function.